From the earliest moments of human consciousness, the vast expanse of the sky above has held an irresistible allure. The sight of birds soaring effortlessly sparked a primal longing within us, a yearning to conquer the heavens. This fascination is woven into our collective imagination, reflected in myths and legends. The myth of Icarus stands as a cautionary tale about unchecked ambition. The quest for flight represents a fundamental human drive to explore and innovate. This enduring fascination has driven us to explore uncharted territories and redefine our place within the vast cosmic tapestry. Welcome to Timeline of Innovations, where we take you through a journey of how everyday things progressed. If you enjoy this video, please don't forget to like and subscribe. The path from whimsical dream to reality has been paved with countless trials and unwavering determination. Early attempts to achieve flight were often met with disappointment and disaster. Yet each failure provided valuable insights, bringing us closer to sustained flight. In the 9th century, Abbas ibn Firnas constructed a glider inspired by birds. He launched himself from a tower in Cordoba, achieving a brief glide. Though he was injured, his attempt marked a pivotal moment in aviation history. Leonardo da Vinci's detailed sketches and designs showcased a profound understanding of aerodynamics. His visionary approach inspired generations of inventors to come. The journey towards conquering the skies began with the gentle sway of fabric and the whisper of wind against wicker baskets. The Montgolfier brothers pioneered the hot air balloon in the 18th century. Their experiments culminated in a public demonstration in 1783. The balloon soared to over 6,000 feet, captivating onlookers. This success ignited enthusiasm for ballooning across Europe. The age of balloons and airships had dawned. Long before the first tentative forays into the sky, the human imagination was already soaring among the clouds. Ancient myths and legends from cultures around the globe are replete with tales of winged creatures and celestial beings. These stories served as expressions of our deepest aspirations and our eternal quest to understand our place in the cosmos. One of the most enduring tales of flight is the myth of Icarus and Daedalus. Imprisoned on Crete, Daedalus devised a daring plan to escape. Using feathers, twine and wax, he constructed wings for himself and Icarus. Daedalus warned Icarus not to fly too close to the sun. Icarus, enraptured by flight, ignored his father's warnings. He soared higher, the sun's rays beating down upon his wings. The wax melted and Icarus plunged into the sea. The myth of Icarus reminds us of the balance between ambition and prudence, yet it embodies the enduring allure of flight. It speaks to our primal urge to explore the unknown and push human potential. This yearning to conquer the skies continues to inspire generations of inventors, dreamers and daredevils. While the myth of Icarus served as a cautionary tale, the 9th century witnessed a real-life attempt at flight that would lay the groundwork for future aviation pioneers. Abbas ibn Firnas, a polymath in Al-Andalus, dared to transform the ancient dream of flight into reality. His pioneering work demonstrated the potential for human flight and inspired generations of inventors. Abbas ibn Firnas, a scholar of diverse interests, possessed an unquenchable thirst for knowledge. Intrigued by bird flight, he studied their anatomy and aerodynamic principles. Using wood, silk and feathers, he constructed a glider-like apparatus. In 875 AD, he launched himself from a tower in Cordoba, Spain. Achieving a brief but controlled glide, he proved human flight was possible. The Renaissance was a period of artistic, scientific and intellectual flourishing. Leonardo da Vinci epitomized this era, excelling as a painter, sculptor, inventor and more. His notebooks reveal a mind captivated by the mechanics of flight. Da Vinci meticulously studied birds to design flying machines. His work laid the groundwork for future aviation pioneers. From the mythical tale of Icarus to the ingenious experiments of Abbas ibn Firnas and the visionary designs of Leonardo da Vinci, the quest for flight has always blended art and science. Ancient myths inspired inventors to transform fantastical visions into reality. Abbas ibn Firnas's glider and Da Vinci's sketches bridged art and science, laying the foundation for modern aviation. The 18th century marked a turning point in humanity's pursuit of flight, moving from mythology to scientific exploration and public spectacle. The Montgolfier brothers' hot air balloon in 1783 captured the world's imagination, altering our relationship with the sky. These brightly coloured spheres ascending ignited a sense of wonder and possibility. Joseph Michel and Jacques-Étienne Montgolfier were unlikely pioneers of flight. Papermakers by trade, they experimented with paper bags filled with hot air. They believed smoke or levity could lift objects skyward. Their early experiments led to a public demonstration that captivated the world. On June 4, 1783, in Annonay, France, they unveiled their creation to an awestruck audience. A large crowd witnessed a 35-foot balloon, constructed of linen and paper, inflated over a fire. As the balloon filled with hot air, it strained against its tethers. With a collective gasp, the ropes were released and the balloon ascended into the sky. News of this feat spread across Europe, igniting a craze for ballooning. The Montgolfier brothers became instant celebrities, embodying the spirit of invention. The skies, once for birds and celestial objects, were now within reach of humankind. While the initial allure of hot air balloons lay in their spectacle and novelty, it didn't take long for the scientific community to recognize their potential for research and exploration. Early balloonists, often referred to as aeronauts, embarked on daring ascents, carrying aloft scientific instruments to study atmospheric conditions, wind patterns, and the Earth below from a vantage point never before imagined. These pioneering flights provided invaluable data that advanced our understanding of meteorology, physics, and the natural world. One of the earliest scientific applications of ballooning was in the field of meteorology. Before the advent of weather balloons and satellites, our understanding of the atmosphere was limited by our ability to make observations from the ground. Hot air balloons provided a platform for scientists to ascend into the sky, carrying barometers, thermometers, and hygrometers to measure atmospheric pressure, temperature, and humidity at various altitudes. These measurements helped to unravel the mysteries of weather patterns, cloud formation, and the circulation of the atmosphere. Beyond meteorology, balloon ascents offered unprecedented opportunities for geographical observation and cartography. While hot air balloons provided a thrilling taste of flight, their reliance on wind currents for propulsion limited their practical applications. The desire for a steerable aircraft, one that could navigate the skies with greater precision and control, led to the development of the dirigible, a lighter-than-air craft equipped with engines and rudders, capable of independent flight. The dirigible, a testament to human ingenuity and our relentless pursuit of mastery over the air, represented a significant leap forward in aviation technology. The concept of a steerable airship had been proposed by visionaries as early as the 18th century, but it wasn't until the latter half of the 19th century that technological advancements made this dream a reality. In 1852, Henri Giffard, a French engineer, constructed and flew the first successful steam-powered dirigible. Giffard's airship, resembling a giant cigar with a propeller mounted on the side, demonstrated the feasibility of powered flight, albeit at a modest speed of around 6 miles per hour. Giffard's pioneering work inspired a wave of innovation in dirigible design and propulsion. The early 20th century was a time of both promise and peril for the airship. Dirigibles, particularly the large, rigid-framed airships known as Zeppelins, named after their German developer Count Ferdinand von Zeppelin, captured the public's imagination, offering the allure of transatlantic travel in luxurious comfort. However, a series of high-profile accidents, coupled with the rapid advancements in heavier-than-air aircraft, ultimately led to the decline of the airship era. The Zeppelins of the early 20th century were marvels of engineering, dwarfing their predecessors in size and capability. These massive airships, some stretching over 800 feet in length, featured rigid internal frameworks, multiple engines, and luxurious passenger cabins, offering a level of comfort and opulence unheard of in air travel at the time. The LZ-127 Graf Zeppelin, one of the most successful Zeppelins ever built, completed over 2 million miles of passenger service, including a circumnavigation of the globe, capturing the public's imagination and solidifying the airship's reputation as a luxurious and reliable mode of transportation. However, the airship's reliance on flammable hydrogen gas for lift posed an inherent safety risk, a risk that tragically materialized in a series of high-profile accidents. As the 19th century drew to a close, the world stood on the cusp of a technological revolution that would forever alter the course of human history. While ballooning and the nascent field of airship design had demonstrated the feasibility of lighter-than-air flight, the quest for powered, controlled and sustained flight remained an elusive goal, a challenge that captivated the imaginations of inventors and dreamers worldwide. Enter the Wright brothers, Wilbur and Orville, two bicycle mechanics from Dayton, Ohio, whose unwavering determination, meticulous experimentation, and revolutionary approach to engineering would propel humanity into the age of powered flight. The Wright brothers' fascination with flight stemmed from a childhood fascination with kites and a toy helicopter gifted to them by their father. This early fascination blossomed into a lifelong passion, leading them to devour any information they could find on aeronautics, from technical journals to accounts of Otto Lilienthal's pioneering glider experiments. The brothers, recognizing the limitations of previous attempts at flight, approached the challenge with a unique blend of practicality, ingenuity, and a deep understanding of mechanical principles honed in their bicycle shop. Unlike many of their contemporaries who focused solely on building powerful engines, the Wright brothers understood that the key to sustained flight lay in mastering the art of control. The Wright brothers' success in achieving powered flight stemmed not only from their understanding of aerodynamics, but also from their innovative approach to engineering and their willingness to challenge conventional wisdom. Drawing upon their experience building and repairing bicycles, they applied their mechanical skills and keen eye for detail to the construction of their aircraft, meticulously crafting each component by hand and experimenting with various materials and designs. Recognizing the need for a lightweight yet powerful engine to propel their aircraft, the Wright brothers partnered with their mechanic, Charlie Taylor, to design and build a custom engine specifically tailored to the unique demands of flight. The engine, a 4-cylinder, 12-horsepower marvel of ingenuity, utilized aluminum for its crankcase and cylinder block, a novel choice at the time that helped to reduce weight without sacrificing strength. The engine, coupled with their innovative propeller design, provided the necessary thrust to lift their aircraft off the ground and into the history books. The Wright brothers' approach to problem-solving extended beyond the construction of their aircraft. They understood the importance of data-driven design and meticulous record-keeping. On a blustery December morning in 1903, amidst the sand dunes of Kitty Hawk, North Carolina, history was about to be made. After years of meticulous planning, countless hours of experimentation and unwavering dedication, the Wright brothers were ready to attempt the first powered, controlled and sustained flight of a heavier-than-air machine. The stage was set for a moment that would forever alter the course of human history, ushering in a new era of exploration, innovation, and boundless possibility. The aircraft, christened the Flyer, was a fragile-looking biplane constructed of spruce wood, muslin fabric, and piano wire. Its wings, spanning 40 feet, were warped and controlled by a system of levers and pulleys operated by the pilot, who lay prone on the lower wing. The 12-horsepower engine, mounted to the right of the pilot, sputtered to life, its rhythmic roar a testament to the Wright brothers' mechanical ingenuity and their unwavering belief in their creation. The Wright brothers' success at Kitty Hawk reverberated around the world, igniting a frenzy of excitement and ushering in a new era of aviation. Newspapers hailed their achievement as a triumph of human ingenuity, while inventors and entrepreneurs alike rushed to capitalize on the potential of this groundbreaking technology. The skies, once the exclusive domain of birds and clouds, were now within reach of humankind, opening up a realm of possibilities that sparked the imaginations of dreamers and visionaries worldwide. The years following the Wright brothers' historic flight witnessed a rapid evolution in aircraft design and capability. Inventors experimented with various configurations, engine types, and control systems, constantly pushing the boundaries of speed, altitude, and distance. The fragile biplanes of the early 20th century gradually gave way to more robust and powerful aircraft, their designs incorporating advancements in aerodynamics, engine technology, and materials science. The Wright brothers' legacy extends far beyond their groundbreaking invention. Their story is a testament to the power of human curiosity, perseverance, and the unwavering belief in the ability to achieve the seemingly impossible. Their meticulous approach to experimentation, their dedication to data-driven design, and their willingness to challenge conventional wisdom continue to inspire innovators and dreamers across countless fields. The Wright brothers' impact on the world is immeasurable. Their invention transformed transportation, connecting distant corners of the globe and shrinking the world in the process. The airplane revolutionized warfare, altering the course of conflicts and reshaping geopolitics. World War I transformed aviation, turning fragile biplanes into powerful war machines. The conflict spurred rapid innovation in reconnaissance, combat, and bombing aircraft. Pilots engaged in legendary dogfights, capturing the world's imagination. Early warplanes were rudimentary, but combat needs drove advancements. Wood and fabric gave way to metal and powerful engines. The war birthed aerial combat, with aces like the Red Baron becoming legends. World War I's impact on aviation extended far beyond the battlefield. It laid the groundwork for future advancements in aircraft design and capability. The post-World War I era saw remarkable aviation innovation. Designers and engineers pushed aircraft performance boundaries, leading to the golden age of aviation. Sleek aircraft, powerful engines, and metal construction techniques emerged, driven by daring aviators like Lindbergh and Earhart. Despite risks, the allure of flight spurred progress. As the world braced for another global conflict, a revolution was brewing in aviation technology: the jet age. Propeller-driven aircraft had reached their limits. Jet propulsion promised unprecedented speeds and altitudes. Based on Newton's third law, jet propulsion was theorized for centuries. Mid-20th century advancements made practical jet engines a reality. Pioneers like Frank Whittle and Hans von Ohain developed working jet engines. The first jet-powered aircraft took to the skies in the early 1940s. The Messerschmitt Me 262 showcased the potential of jet propulsion. Its performance left no doubt that the future of aviation lay in the jet engine. The jet engine revolutionized air travel in the post-war era. Jet-powered passenger aircraft dramatically reduced travel times, jet aircraft bridged continents in hours, transforming global connectivity. The Douglas DC-3 revolutionized air travel between the world wars, transforming it from a luxury to an accessible mode of transportation. Introduced in 1936, its all-metal construction and powerful engines set new standards for speed, altitude and passenger comfort. The DC-3's economic efficiency made air travel profitable, fueling the growth of commercial aviation. During World War II, its versatility and reliability made it invaluable for military operations. The DC-3, affectionately called the Goonie Bird, became a symbol of American industrial might. The transition from propeller-driven aircraft to jet-powered aircraft marked a profound shift in aviation, transforming speed, altitude, and our relationship with the sky. The jet engine's unparalleled speed and efficiency revolutionized air travel, shrinking the world, connecting distant cultures and transforming military aviation. The jet engine is a testament to human ingenuity and our pursuit of the heavens. In 1947, Captain Chuck Yeager broke the sound barrier in the Bell X-1, redefining aviation history. The sleek, rocket-powered Bell X-1 pushed the limits of speed and human courage. Breaking the sound barrier was a monumental challenge, but Yeager's flight proved it possible. This historic achievement inspired future generations of engineers and pilots. Chuck Yeager, a World War II fighter ace, was chosen to pilot the Bell X-1 on its supersonic quest. The X-1 was air-launched from a B-29 bomber to conserve fuel and accelerate in thin air. On that day in October 1947, Yeager ignited the rocket engine, propelling the X-1 towards the sound barrier. With a thunderous boom, the X-1 broke the sound barrier, making history. The breaking of the sound barrier was a symbolic victory over a psychological barrier that had long constrained human ambition. For years, the sound barrier was seen as an impenetrable wall in the sky. Yeager's flight shattered this misconception, inspiring a generation to push the boundaries of aviation. The sound barrier is a region of rapid change in aerodynamic forces and airflow patterns. As an aircraft approaches the speed of sound, air molecules compress, creating a shock wave. This shock wave disrupts airflow, leading to increased drag and changes in lift and stability. Early attempts to break the sound barrier often ended in disaster. Aircraft experienced violent buffeting, control problems, or structural failure. These failures fueled a relentless pursuit of knowledge and innovation. Swept wings, supersonic airfoils, and advanced materials overcame the challenges of supersonic flight. Swept wings reduced drag, allowing higher speeds before severe transonic effects. Supersonic airfoils minimized drag and improved stability at high speeds. Advanced materials like titanium and composites enabled aircraft to withstand supersonic stresses. The breaking of the sound barrier ushered in a new era of supersonic flight, an era characterized by sleek, powerful aircraft capable of traversing vast distances at speeds previously unimaginable. Among these supersonic pioneers, the Concorde stands out as an icon of aviation history, a testament to human ingenuity and our enduring fascination with speed and technological prowess. The Concorde, with its distinctive delta-wing design, drooping nose and four powerful Rolls-Royce Olympus turbojet engines, was a marvel of engineering for its time. Capable of cruising at twice the speed of sound, Mach 2.04, at an altitude of 60,000 feet, the Concorde could cross the Atlantic Ocean in a mere 3.5 hours, slashing travel times in half and shrinking the world in the process. Passengers aboard the Concorde experienced the ultimate in luxury air travel, enjoying fine dining, attentive service, and the thrill of soaring through the stratosphere at supersonic speeds. The Concorde's maiden flight on March 2, 1969, captivated the world, ushering in a new era of supersonic air travel. For a brief, shining moment, it seemed as if supersonic flight would revolutionize commercial aviation, connecting distant corners of the globe at unprecedented speeds. However, the Concorde's reign as the queen of the skies would prove to be short-lived, plagued by high operating costs, limited routes, and concerns over noise pollution from its sonic booms. The sonic boom, an unavoidable consequence of supersonic flight, proved to be a major obstacle to the Concorde's widespread adoption. As an aircraft travels faster than the speed of sound, it creates a continuous shockwave that trails behind it, similar to the wake of a boat moving through water. When this shockwave reaches the ground, it is heard as a loud, thunderous clap, known as a sonic boom, which can be startling and disruptive to those on the ground. To mitigate the impact of sonic booms, the Concorde was restricted from flying at supersonic speeds over land, limiting its routes and reducing its commercial viability. The Concorde marked the peak of supersonic travel, but the quest for speed continues. Engineers and scientists are pushing the boundaries of hypersonic flight, exceeding Mach 5. Hypersonic flight presents unique challenges, like intense heat and extreme pressures. Advanced materials and thermal protection systems are essential. Innovative designs ensure stability and maneuverability. Hypersonic flight could revolutionize air travel and military applications. Imagine crossing continents in minutes. Hypersonic missiles offer strategic advantages. Hypersonic spacecraft could revolutionize space exploration. Experimental aircraft and scramjets are pushing speed limits. Scramjets enable hypersonic speeds without heavy oxidizers. Hypersonic gliders are being tested for advanced systems. The quest for hypersonic flight showcases human ingenuity. The dream of hypersonic flight is becoming a reality. Human determination continues to conquer the skies. The quest for speed in the skies led to dreams of reaching the stars. The Wright brothers' success ignited visions of space travel. Transitioning from airplanes to rockets marked a shift in thinking. Rockets use Newton's third law to generate thrust. Early pioneers like Tsiolkovsky, Goddard and von Braun laid the groundwork. Liquid-fueled rockets marked a turning point in spaceflight. They offered throttle control and in-flight restart capabilities. The Space Shuttle Columbia's launch in 1981 marked a new era in spaceflight, characterized by routine access to low Earth orbit. The shuttle program achieved significant milestones, including deploying the Hubble Space Telescope and constructing the International Space Station. Despite its successes, the program faced challenges, including the tragic losses of Challenger and Columbia. These events underscored the risks of spaceflight and the importance of safety. As the Space Shuttle program ended in 2011, a new era in spaceflight began. Driven by private industry and reusable rockets, companies like SpaceX and Blue Origin lead this new space race. Their ambitions extend to the Moon, Mars, and beyond. While the Moon, Mars, and other destinations within our solar system remain tantalizing targets for exploration, the human spirit of curiosity compels us to look beyond the horizon to the distant stars and the possibility of interstellar travel, a journey that represents the ultimate triumph of human ingenuity. Interstellar travel presents a formidable challenge, one that dwarfs even the most audacious space missions. The vast distances involved, measured in light years, necessitate propulsion systems far beyond our current capabilities. Despite these challenges, the allure of interstellar travel remains strong, fueling theoretical research into advanced propulsion concepts. The pursuit of interstellar travel serves as a testament to the boundless possibilities of human imagination. The journey to the stars will require technological breakthroughs and a fundamental shift in our understanding of physics. It will require a collective effort, driven by a shared sense of purpose. The quest for interstellar travel represents the pinnacle of human ambition, a testament to our innate curiosity and our unwavering belief in the power of human ingenuity. While the journey may be long and fraught with challenges, the rewards, both in terms of scientific discovery and the expansion of human knowledge, make it a journey worth undertaking. As we ventured further into the cosmos, a more intimate form of flight was taking shape closer to home. The wingsuit, a marvel of lightweight materials, allows humans to glide like birds, embracing gravity and lift in a breathtaking dance. Modern wingsuits, crafted from durable materials, feature inflatable airfoils that generate lift, allowing horizontal gliding. Wingsuit flyers launch from cliffs, airplanes or helicopters, transforming into human gliders, carving graceful arcs through the sky. Wingsuit flying is a form of flying meditation, a state of heightened awareness and intense focus, navigating canyons and mountain ranges. The dream of personal flight, a dream as old as humanity itself, has long captivated inventors, dreamers and science fiction writers alike. While flying cars and jetpacks have remained elusive for decades, relegated to the realm of futuristic fantasies, recent advancements in battery technology, electric propulsion and lightweight materials have brought the tantalizing possibility of personal flight devices closer to reality. Electric vertical takeoff and landing, or eVTOL aircraft, often resembling oversized drones with enclosed cabins for passengers, are emerging as a promising contender for urban air mobility solutions. These aircraft, powered by electric motors and batteries, offer a quieter, more environmentally friendly alternative to helicopters and traditional aircraft for short-haul flights, particularly in congested urban environments. Jetpacks, once the stuff of science fiction, have also made significant strides in recent years. Advances in miniaturization, lightweight materials and fuel efficiency have led to the development of jetpacks capable of lifting a person vertically into the air for short periods. While still in their early stages of development, jetpacks hold the promise of revolutionizing personal transportation, search and rescue operations, and even recreational activities. The rise of personal flight devices raises a number of challenges, including safety regulations, airspace management, noise pollution, and the potential for misuse. However, the potential benefits of personal flight, in terms of reducing traffic congestion, providing rapid response capabilities for emergency services, and enhancing personal mobility, are too significant to ignore. As we look to the future of flight, the possibilities seem as boundless as the sky itself. Innovation in aerospace engineering, material science, propulsion systems, and artificial intelligence is driving a new era of aviation, one characterized by increased efficiency, sustainability, autonomy, and the exploration of new frontiers, both within our atmosphere and beyond. Electric and hybrid electric aircraft powered by batteries, fuel cells, or a combination of both are emerging as a viable alternative to traditional fossil fuel-powered aircraft, offering the potential for reduced emissions, lower operating costs, and quieter operation. These technologies, already being incorporated into small aircraft and drones, are poised to transform commercial aviation, making air travel more sustainable and environmentally friendly. Autonomous flight systems utilizing artificial intelligence, machine learning, and sophisticated sensors are rapidly advancing, promising to revolutionize air travel, logistics, and even military operations. Autonomous drones are already being used for a variety of applications, from package delivery to aerial photography to infrastructure inspection. The development of fully autonomous passenger aircraft, while still facing regulatory and societal hurdles, holds the potential to increase safety, efficiency, and accessibility in air travel. Supersonic and hypersonic flight, once the exclusive domain of experimental aircraft and military jets, are once again capturing the imaginations of engineers and entrepreneurs. New materials, propulsion systems and aerodynamic designs are being developed to overcome the challenges of high-speed flight, promising to dramatically reduce travel times and connect distant corners of the globe at unprecedented speeds. From the earliest dreams of flight to the supersonic jets and reusable rockets of today, human aviation is a journey of relentless innovation and ambition. The future of flight is about leveraging technology to address pressing challenges. Sustainable aviation can reduce our environmental impact and mitigate climate change. The spirit of innovation lives on in engineers, scientists and dreamers around the world. As we reach for the stars, we must reimagine our world for a sustainable, equitable future. That concludes our journey on this episode of Timeline of Innovations. Please like and subscribe, and don't forget to hit the bell button to be notified of upcoming episodes where we venture into another journey of the progress of everyday things.